This, I mean, just I showed this. This is the part of the presentation I gave back in I think it was November to the whole group. So this is, I mean, this is where I started. It's with astrophotography 3 years ago when I got an observatory, and at the time I had Skywatch Ray-Z EQ6 mount, a GTF 81, which is a William Optics 3.5-inch scope, a Nikon D90, an intervalometer, and these are the two first images that I ever took. So that's Andromeda, that's M27, and these were in July, so just less than 4 years ago, and they were about 10 minutes in total, and I was absolutely over the moon with these because I had absolutely no idea at all that I could get anything out of the kit I had, and I'd seen some stuff on Instagram and whatever, and I just thought I'd have a go, and this is what I came up with, and it was stacked in Deep Sky Stacker, so it was and Photoshop. I had no idea what I was doing. Anyway, that's what came out, and that's what really started me on the journey, which is, as I think I've told lots of people, it's cost a huge amount of money so far. The first thing I did after that actually was to join the Basingstoke group in September of 2017. Met all you nice chaps, and the next thing I did, I mean, I was trying to take photographs with the kit I had, which was the GTF 81, the mount, and I also had a Meade LX200, 10-inch LX200, which I tried to take photographs with, which was terribly unsuccessful because it had mechanical issues and all sorts of terrible optical issues too. Then I went out to Australia with a Nikon, a Canon 600, which had been astro modified, and a 3500 5mm lens, a Star Adventurer, and photographed some of the things in the southern hemisphere. So that's Eta Carina, and that's the two Magellanic Clouds. So these are, what does it say? These are about 10 minutes. These are 10 minutes. So the reason I'm putting these up is just an illustration of what you can do with a DSLR. I mean, these things are really quite bright, and the skies where I was in Australia, much darker than they are around here. So you'd probably need to expose a bit longer to get anywhere close to these. But this is just really what I was doing at the time. Anyway, how do I do my images? Well, the thing I found out really is that in order to get an image of the quality that I wanted, you just need tons and tons and tons of data. So this is what I did for M31 back in September, and be 10 minutes. So it's 256 10-minute subs in luminance. Oh, sorry, there you go. Luminance 36 times 10 minutes. That's 6 hours, 3 hours, 3 hours, and 4 hours in red, green, and blue. And then some HA as well. We got as well on a different scope, but not gonna worry too much about that. So that's, I think, 3, 4, 5, 6, 7. That's 7 hours, isn't it, in total of data went into the image, and that's how you get a good good data. Now, if you've not got a permanent observatory, I think it's extremely unlikely that you'll be able to do that. You just won't have the patience or the time to get that kind of stuff, and you probably not. I mean, I'm using a mono camera with filters, which is a bit faster as well than a color camera. But that's fundamentally how you get it. You get loads and loads of data to do it now. But once you've got that, what do I do? Well, I look at all the individual subs that I've got. So within PixInsight, there's a thing called Blink, which allows you to basically look at all the subs to see whether they've got any trailing issues, or there's clouds coming over, and you can see as you blink through them, you can see if there's clouds coming through, because you'll get the illumination across the field will change as it goes through. And also a thing called Subframe Selector, which allows you to measure things like the star size, signal to noise ratio, whatever on it, and basically chuck out the rubbish. You really do want to get rid of any bad frames out of before you start to integrate, because they will make a mess of it all. Then to create master light frames for each filter, you have to calibrate the images. I'm pretty sure people know this. So you need to remove what's called the bias signal, and also something called the dark current off it. And that gets and that gets you just to the signal that you get from space and from well, the signal that comes in through the front of the telescope, basically, by taking these sensor signals out. And you do another thing called flat fielding, which removes any optical effects in the telescope. So any vignetting, any dust bunnies, any different sensitivities on the sensor. That's flat fielding, and you use those to calibrate your images. Once you've got your calibrated images, you have to register them all together. Again, I do that in PixInsight, and you just select a reference frame, which is generally the best frame that you've got out of subframe selector. Register them all, and then integrate each of the different channels, red, green, and blue luminance, together. And I generally stack them in something called AstroPixel processor. Right.
You mentioned there, Dave, on there you got using PI-TPS.
Thin plate splines, and the reason I do that, is because I'm using two different optical systems. So
of course,
so there's slight distortions between the two. That they might not look like they are, but there's definitely slight distortions between the two.
Yeah, because you brought your HA in at the same.
Of a different optical systems, they have to use some sort of distortion correction.
Now, one of the other things that you haven't mentioned there before you plow on and do, I apologize if I'm jumping ahead a bit.
No.
But within the book that is like the Bible of PixInsight at the moment, he mentions in there, and I think it's a very, very good point, is do you only want to, excuse me, you only want to do your registration once. So don't do, each filter's worth and register them to make a master in each. Just register once across the whole lot.
That's right. They just register all the frames to one reference image. Actually, if anyone's using APP, I mean, you don't. All APP does, you put all your raw data in, and then the whole lot just pops out, and all you get at the end of the stacks. You don't have it yet. You don't have a whole pile of calibrated images. So
well, Cyril does exactly the same.
Yeah.
So you can run Cyril using scripts, and it will calibrate, register, and stack
the whole lot.
The whole lot. You can in PixInsight as well if you want to use the weighted batch pre-processing. But obviously there's the pros and cons of the amount of control you have.
Yeah. Well, at the moment we're happy for the app to have the control, because the main thing is to get an image out of it. Then we can start looking at how we're going to improve that. So that's good news. So the steps you're doing are exactly the steps that we are doing as well.
Yeah, I haven't invented anything new. Yeah, I mean, what cameras are people using? Are you using DSLRs?
Yes, mainly, yes.
Yeah.
Yes.
Are they Canons or Nikons or?
There's a mixture of Canons and Nikons. So,
because I think you might find with, I think the Canons are okay. I mean, you're all using raw data out of your cameras.
Beginning to, yes.
You need to do that.
Yeah, we need to use raw. Yes.
For your individual your specific cameras that you've got, it's worth doing a search on whether, particularly for the Nikons, whether it's really raw data that's coming out, and because it has an effect on, particularly on the flat calibration on them, because some of them, my Nikon, I got a D750, which is a full frame camera. You would expect it to give proper raw data, but it doesn't. It does something odd with it.
Yeah.
A bit of compression in it, which causes a real issue with flats.
Same with mine.
Yeah.
So Michael, you've got
Yeah.
Yeah, there are workarounds apparently for it, and if you looked at your histogram for the flat, you can see exactly what's going on. Basically, you get steps in it for some reason.
okay.
Say that again, Dave.
Yeah.
But there's also, there's all sorts of stuff out there on the internet where people have come across these problems. There's a bloke actually, Mark Shelley, who is occasionally writes on Stargazers Lounge, more commonly on Cloudy Nights, who is an expert on all this stuff. So he's if you have problems with your cameras, with particularly flat field or anything, he's DSLRs. He's a chap to search out his opinions. You'll search, you get loads of stuff coming up, but if you find an opinion from Mark Shelley, it's usually worth listening to. So that's what's going on. I've got and I take darks, flat darks, bias, you integrate them all into your masters. I use match darks for everything. So I've got two cameras. I've got a CMOS camera and a CCD, and I with a CCD I would take 5, 10 or 20 minute exposures at -25, and I just take darks to match those and take those out. And it's the same with the CMOS camera as well, except for that I use 1, 2 and 5 minute exposures. Flat frames calibrate with flat darks before integrating to the master flats, and then calibrate your flats, and then integrate all your calibrated flats into master flats. Again, if you don't get your calibration correct, you can end up with under or over correcting flats. So if after calibration of your light frames you get corners in that are brighter or darker than you think they ought to be, because it should be flat if you've still been calibrated properly. Generally, it's because your calibration has gone wrong. So there's something wrong with the bias or the dark usually that causes that.
Dave, did you see Mark's question?
I haven't, no, because I don't know how would I see that.
I was just asking, Dave, so if you're exposing over multiple nights, if you're capturing this data over multiple nights, do you take one set of darks and flats at the end, or do you take them as you go, one per night?
It depends, because I've got a set point cool camera and I take my darks and they last a long time. They last months generally.
Because you're at that constant temperature.
Constant temperature in this.
Yeah, gotcha.
Might get a bit, on the CCD in particular, you'll get cosmic ray strikes, whatever, which will change stuff over time. But really, I just take them every couple of months.
Gotcha. Okay, thank you.
Yeah.
And you do that purely because you can set your camera to a temperature, yeah?
Yeah. And the flats, I take the flats every few months as well, because it's the sealed system. It doesn't, and nothing happens. If I do get, if I after calibration of a set of images, I find that there's a dust bunny or something, I just go and take another set of flats. And just run them through again. But if you're setting up and taking down every night, you probably need to take you do need to take your flats
each time. Yeah. Okay. Thank you.
And how critical do you find the flats and focus? If you change focus, should you redo your flats?
I don't know. No, I've never noticed it make any difference. It might.
It will really depend on what the ambient temperature differences are between different nights. as to how much you have to move your focus in order to re-get that sharp point. And if there's been a big difference, then your flats are going to potentially have more of a problem.
Well, presumably the longer the focal length, the worse it gets, I imagine.
Yeah, that's it as well. So if you're taking wide field, you've got the most latitude to play with. But yeah, if you're as soon as you
can I ask the group if, especially the First Light group, do they understand what a flat is? I know we have spoken about it. I'm curious to know, Dave, how you take a flat in the dark.
Yeah. I've got a light panel.
You've got a light panel.
And,
so if you don't have a light panel, you have to wait for some sort of light.
You have to wait for daylight. Yeah.
Daylight and a few layers of clean white sheet that you've managed to pinch off the ironing pile.
Yeah. I have tried using a iPad as a light panel. Will that work?
It can do. It depends how much much blue there is, because if you haven't got an even spectrum, then if you're using different filters or whatever, then you can see an effect. But yeah, it does depend on
because all I did was open a Word document on the iPad, got the whole screen blank, prevented it from switching off or dimming, and that's it.
Yeah. I mean, I know a lot of people that have good success with that, and there's various pros and cons that you can read about on the forums. But yeah, you'll soon know if they're working, particularly once you start getting into more color, and if you do progress to using a hydrogen alpha filter or anything like that, then that's where you'll know how broad a spectrum of light your flat is actually generating.
I see. Okay.
Yeah. Sorry, Dave. Interrupt.
No, I'm completely confused with what I'm trying to do now. I'm trying to share.
And the other thing that I get, Dave, is one corner of my image is always bright. I'm guessing that's amp glow or whatever it is. Yeah.
With which camera? The 224?
This is the ASI 224.
How bright? I mean, I'll just talk about flats for a minute. So this is a flat. It's a flat from my Esprit 150. And
you sneezed, did you there, Dave?
No, I didn't know. Obviously, didn't clean them out properly. If I take the stretch off, I mean, it just looks completely flat, doesn't it?
Oh yeah.
It's only when you put the auto stretch on that you can see anything on it. Now, so these round things, they're little dust bunnies. They're actually on the which ones are these? These I think are
on the filter.
Camera. No, they're not on the filter. They'll be much bigger.
Really?
Yeah. They're on the cover slip.
They don't look as sexy without the hole in the middle, Dave, I have to say.
No, I know. So I haven't actually got any dust on my filters. But if you actually went in and measured, we can do this. And if you measure, this is a little, I don't know if you can see this little number down at the bottom, but that's 4168 in that corner and 4214 there and 4231 there. So it looks dark, doesn't it? It looks dark down here. But actually, the difference in illumination across any of this is less than 1% anyway. It's only because you've stretched it. And with a screen stretch on a flat, this is the stretch you put on this is probably much harder than you'd ever put on an image. It's just it's a really extreme stretch.
The other way you can demonstrate that, Dave, is if assuming you've got it, if you go on to scripts and then utilities, and then that was it, that's the one. Yeah, click on that one, and it'll give you, yeah, and now do point STF, so you can see the thing again. Down in the bottom, no, down in the bottom of the where the image name is, left-hand pane of that. It's got STF just towards the end of the name.
Right a bit, fire.
That's it, fire that one.
I put my glasses on, I don't know.
Yeah, right. So now you can see if you change the visualization bars that are on the left-hand side of the screen. No, not that bit, but the white. Bring the white down. That's it. And now take the black up. See, that's the curve of the light difference, and you can see they're almost exactly the same number as you demonstrate. So that's another way of doing it. And you can go on diagonals and you can choose where you go on that thing. It's actually
okay. That's showing the variation across the flat.
That's
yes.
illumination variation.
Just along that line. That's all it's reading is the line you see.
Move the line.
You can go to different. Just click anywhere in the picture, and it will shift. And you can do diagonals as well, Dave. If you look just above where the image name was, you can see diagonal. You can do vertical, diagonal, down, diagonal, up.
Very clever.
Yeah, it's very handy for monitoring what's going on. I use it quite often with the old exoplanet stuff, is just to see whether I've got a decent signal there or not against the.
So why do you want to go to this level on a flat?
Sorry, what?
Why do you want to look at it in this much detail on a flat?
No, it's just I was just showing that out of curiosity so you can see what it's doing. That's all it is. It's just it's explaining the virtues, benefits, etc. of a flat, and it's just a way of analysing what you've got on a flat.
It shows, yeah, it just shows you. I mean, mainly the effect you get is vignetting.
Yeah, you've got very little there.
Yeah,
virtually nothing.
There's a quick comment about Pramod. Just to share an experience. Have you got a Newtonian, Pramod, or other? You're on mute, by the way.
Muted. Pramod.
It's a Newtonian.
Okay, so here's a weird one. I was getting all sorts of weird effects, and I suddenly came to realize that because I was in the observatory and I had the little pod and I had my laptop set up and bits and bobs, it's a bit of a strange confession. You realize that the bottom end of a Newtonian is transparent to light. So if you get your head torch and aim it at the bum end of your newt, you will see red light coming out the top end. So any light leaching that you've got, any little lights, the little blue lamps on your power supplies, anything will shove light up the back end.
No, the bottom of my newt is totally sealed.
Okay, because my Skywatcher wasn't, so I had to make a little bum back.
This is a really I didn't expect the kind of images at all from my newt. It's a 130 EQ Celestron. It's like what you said, right? You pay a lot, but you get a bummer. So it's apparently got a spherical mirror, and I've heard enough people saying it's a no good scope. But yeah, I've managed to get pretty decent.
I mean, it is what you've got, isn't it? I mean, people are just using what they've got to find out what they like the whole concept before doing anything different.
Yeah.
Thing is, you learn so much from your first set of equipment that makes you should hopefully make you far better informed for when you've collected your pennies together to go for a second round of spending. So, wring its neck basically to learn everything you can.
Exactly what I'm doing.
Yeah. Sorry, Dave.
So we've got having done all that, having done the calibration and the integration, I get my what they call the red, green, and blue masters, and then combine them together in PixInsight's got a process called RGB channel combination. Put them together, and then you end up with this image on the right, which has got in PixInsight, it's got a screen transfer function applied to it, so it appears stretched. Now I don't know. Does Cyril do stretching? Does it auto?
Yes, it does.
so you can actually see what the things look like.
Yeah,
So
I think the general term, before it's actually changed anything permanent with your data, they generally just term it visualization, but it's stretching without changing the numbers.
Yeah, so that's a stretched image that I get, and you can see. First thing you can see is you've got Andromeda in the middle, but you've got a gradient going sort of red at the top, and goes red through green into the bluey green. So the next thing that you need to do, is to get rid of the gradient. And again, PixInsight has got a, and you do this well. So this is unstretched, so it's in what they call the linear mode. So the values. So what you do is you get rid of the gradient using some tool or whatever in the linear mode. Yeah. So PixInsight's got two tools for doing that. It's got something called dynamic background extraction, and it's got another thing called automatic background extraction. And I don't tend to use automatic background extraction, but dynamic background extraction are used quite a lot. Or APP has also got a method which is pretty similar to dynamic background extraction, where you go into the image and you place points all around in places where you think you've got background sky, basically, so that it can measure the gradient, and then it extract that. So I need to do background extraction on my color RGB image, on my luminance image, and on my XA image, which we're not going to really talk about here. And you need to be really careful, depending on you always need to be really careful about where you put your points to take the gradient out. And the thing to do is not to look at the image that results from you taking the gradient out, but to look at the gradient that you've taken out, because it should be smooth, because it is smooth. So this is the gradient that I took out of the luminance image. So it's sort of darker down there, and it's kind of linear, isn't it? It goes from dark to light diagonally across the frame, and that's just this difference in sky glow. That's as Andromeda, for one reason, it's probably upside down, is it? But the sky is darker at the top than it is at the bottom, and that's really all you're seeing coming out. You might see, depending where you are, you'll see the effects of street lights and whatever. That's what it should look like when you're taking it out. What a lot of people do, and this is the same for the red, green, and blue. So if you can, I don't know if you can see the points here. There's little X's. Yeah, so I just put them right around the side, and I know that Andromeda has got a halo that actually goes right out the side of the frame. It's huge. It's absolutely huge. So if you put any points in the halo, dynamic background extraction will do something funny, and I'll demonstrate what it does in a later slide. But anyway, that's taking it out of the RGB, and you can see the red through green to sort of turquoise color coming out, and what you're left with is this. There's still a residual gradient on it, but I don't stretch the sky so much that it actually shows. So that's that. This is what happens if you put if you just sort of go into automatic mode and let the tool put points all over the place. So it's done it. It's a whole sort of matrix of X's there that it's using to extract the background. And you can see what you've actually done. If you look at the background that was taken out, you've actually taken out the halo of the galaxy, because you can see it there. That's what's happened. And you can see, and you quite often see this in images of Andromeda and other galaxies. It's got a dark ring around the outside where you've taken out the gradient, where you've taken out the halo. And you'll see that quite a lot on people who are just not aware that's what they're doing. Anyway,
Yeah,
so,
Cyril allows you to do exactly the same.
yeah.
And so it'll automatically generate them, or you can randomly do it.
A good trick. I mean, I don't. The sort of things, I guess, the sort of targets that people will be trying will be things like, Andromeda, the Orion Nebula, and the Pleiades, and they unfortunately don't have a lot of background sky around them.
Yes,
you do have to be careful where you put the points, and a good thing to do would be to look at an image, a processed image of those objects, and to find out where the background sky really is, and to use that as a guide as to where to actually go look at the background sky.
To where to place your points, yeah.
So, yeah. Okay.
Mm-hmm.
So the next thing to do would be to calibrate it. You're taking the background out, but you're still not really sure that the thing is the proper color. So this is the thing you have to do, which is color calibration. I tend to use PixInsight's photometric color calibration, which basically looks at goes into the image and chooses some unsaturated stars, but by which I mean stars haven't where the CCD sensor hasn't saturated, so it's stuff that's kind of right in the middle of the range, so pixel values around some way either side of a half, but not above 0.8 or something, I'd imagine. And it uses those stars and it uses a database, and then it does some sort of calibration on it to get you to check that the image is the right color, and then applies some sort of correction to the image to get you back. Another way, yeah,
we do exactly the same in Cyril.
Has it got photo? Does it use photometric?
Yeah. Yes. Yeah.
Yeah. And then having done that, got the image basically the right color. It's probably gone a bit green now, which tends to be what happens.
Yeah.
There's another thing I do, which there's a tool in PixInsight, which is a script which you can repair the star cores. So what it does, it searches through all the stars for those that have got cores that are very high, basically very high pixel values. And what it does is quite clever. It looks around the outside of the star, but what the color is around the outside of the star, where the brightnesses are a lot less, and replaces the pixels in the middle with the values from the pixels on the outside. So it puts the color back into the cores. I don't know if Cyril will have something like that. I'd be surprised.
The answer to that is I don't know, because we've never gone into doing this method, this level of tweaking. But I'd be surprised if there wasn't something there.
There's probably something to repair. I mean, Photoshop can do it, so I imagine GIMP can do it. I mean, it doesn't do it at this stage.
We do have the arcsign stretch
coming on
in Cyril.
Yeah. Coming to that next. Yeah, but Photoshop can do it, where it will do the same kind of thing. It will put the color from outside in the core of the star, and I imagine GIMP's probably got something similar.
Yeah. We'll have to have a look and see.
Because when you do the color calibration, it looks at the stars and then says, okay, I'm coloring these stars. It recognizes the following stars, and therefore it goes and starts applying color to those stars.
Yeah, but it'll adjust the whole lot, won't it? So it'll take.
I don't know how it does it. Whether it colors each star individually, I don't know what it does.
It'll just do some kind of average across the whole frame, I imagine. Well, it doesn't.
No, it doesn't seem to do that, because that's how when I took the image of some of those things, you found a few red ones, a few blue ones. That's all done by Cyril. So I don't know what it does.
So when sometimes when you start out, you'll see stars that have got red, or generally it's red or sort of purple halos around them. And when you do the color calibration, that's gone. It's gone.
Hmm.
And that's because it's adjusting the brightnesses of the different channels. That's what's happening now, I think.
Yeah, I don't know what it does.
Yeah. And then the next thing to do is arc sign stretch.
Okay, so you use arc sign stretch.
Well, yeah. And what that does, the stretches you do are non-linear.
Mm-hmm.
And if you know, I mean, colours, the colours that you have in your image, it's a ratio. So the reason you've got a particular colour on a star is because it's a ratio of red, green, and blue. But they'll be at different points. So the blue might be 0.2, the red might be 0.5, the green might be 0.3 or something. You know, and if you did a normal histogram stretch, you'd stretch each of those values differently. So you'd change the color of the star by stretching. And what arc sign stretch does is it applies the same stretch to everything, so that it keeps the ratio of colors constant.
Mm-hmm.
And you'll see, if you've used it, you'll see that it can do some really funny things, but it produces really rich color in the stars. So that's the first thing I do. And then the second thing I'll do will be just the normal histogram transformation, just like a levels transformation, whatever, in GIMP.
Mm-hmm.
And then if I'm really, really lucky, I'll go back and do a mask stretch, which again will retain the color within the stars, because it's a star color that you lose. You don't tend to lose the color so much in nebulosity. It's the stars, because they're so close. When you stretch them, the pixel values are so close to 1 that everything just goes to white.
Mm.
And there's a chap called Barry Wilson, who's quite a renowned astrophotographer, who's got his own website, and I've used the tutorials off his site for this.
Who is this? Barry Wilson.
Called Barry Wilson, yeah.
Yeah.
But this presentation's on the Google Drive.
Is on what? Sorry.
It's on the BAS Google Drive. I just loaded it all up yesterday.
Right.
Together with some data that we can have a look at in a bit.
Yeah.
So there, it's just an image just showing the stretching, and another key point, which is not to clip the black point. So do you just show a histogram of what you're doing? But what you need to be careful of when you do it is you always need to leave a bit of space over on the left.
Mm-hmm. Yeah.
Look in the blacks. I know it's very tempting. I mean, it's something. I mean, when I started out, the thing about the black stuff, the background sky, is that the signal level is very low there, so it's very noisy, and the temptation is always to black clip it to get rid of the noise. But if you do that, you will get rid of. You'll get rid of the andrometer. You'll get rid of the halo. So having spent hours and hours and hours potentially gathering data, you can destroy it. You can just get rid of it at a stroke of a mouse. You can just get rid of it all. That's a thing to look at. So always leave a bit. Always leave a bit on the left of the histogram until you finish. Basically, you can pull it in right at the very end. That's what I do. Set the black point. It's about the last thing I ever do. Yeah, so you can see here. Now that's what happens with the black point. You can see the halo going right out. At least I can on my screen. I'm not sure how it comes out over Zoom, but the halo is out here somewhere, and it goes right around M101. But if you clip the black point, and this is not coming very far at all, you've just got rid of it. It's just left the core, basically. So something not to do. So this is RGB that's come out of the arc sign stretch, the histogram stretch, and the mask stretch. So that's me done with Pixing site for a while. Actually, I haven't done any noise reduction yet. And I think when I first started, I read all the tutorials and did all the stuff, and it said the first thing you do noise reduction. You know, so that's what I used to do. I used to do a load of noise reduction at the start, and then I'd wonder at the end why there was never any color in any of my images. And the reason was that I'd just removed it with the noise reduction. So I don't do any now until the end. And there's lots of different sort of schools of thought on it, but I do it at the end. I mean, my data's, you know, there's a lot of hours in it, so it's pretty clean. But I do it at the end. The thing I'd always recommend is, once you've got your data, run through it all without, you know, just run through it all pretty quickly, stretch it up and just see what it looks like, to see what you've got, and then start again, rather than kind of embark on a once only process. I mean, I go around a couple of times usually until I'm happy with what I've got, because you'll see when you get to the end of it, you'll see things that you could have corrected earlier in the process. So that's my RGB. So in PixInsight, these are all 32-bit images, but Photoshop only operates in 16 bits. So I have to save it as a 16-bit.
Right.
Serial is presumably, is it 1632, whatever. As long as it's not 8.
32.
Nice. I think yes.
But GIMP, I think, is 16, isn't it?
No.
Yes, it can take 16, but I think recently they've upgraded. It can take 32. I think.
Yeah, I think it's 32 now.
Yeah.
So anyway, I'll take that into Photoshop. On my luminance, stretch, do it. You know, do it. I do it in little increments to get to that. I've got them, and then what I do to enhance color in Photoshop is I do this every time. I take it in, and it's in what they call RGB mode, and I'll change it into something called lab mode, which is, I don't know what it stands for. What it's called, it's just LA and B. So L is lightness, pretty akin to luminance. A is the green to red channel, and B is a blue to yellow channel. I don't really understand it, but what I do is boost the contrast in the A and B channels.
Okay, we'll have to have a look at this. So
you can do that. You can do that. I did look in GIMP, Keith. You can change it into lab mode and adjust the contrast or put a curve on it or something to increase it. And the reason, I mean, this is sort of the recommended method for increasing saturation. The reason you do it in lab mode is because it doesn't add color noise, and not as much color noise as if you just went into the saturation button and whacked the saturation button up.
Okay.
So it's a better method. So there must be a way in GIMP of doing it, because you can go into lab mode in GIMP. I did look at that, but I don't know my way around the menus.
No. That's the idea. We can have a look and just see what we need to do to get into these modes.
Can you do that in PI as well?
Yeah, you can. Yeah. If you just do channel extraction in. I mean, well, there's probably a smart way, and there's probably someone's written a script for it, Dave. But
yeah, well,
we could get John to write a script for it. But
the thing there is, a lot of these scripts are fantastic, but you learn to use them rather than to learn what they're really doing and why they're doing it. If you see what I mean. It's a bit like learning to read without actually knowing the alphabet.
Yeah,
as it were.
We can look at some of this a bit later. But what you do in PixInsight is you just do channel extraction LAB. That's all you do, and then you'd use a curve tool to put an increased contrast on them. You have to be careful not to move the point in the middle, otherwise you'll change the color cast. But you can just put an S-shaped curve through it to both the A and B channels, and then combine it back together, and the saturation will have gone up. So so I do that, and then the next thing, convert it back to RGB color space, and then in Photoshop I create 2 duplicate layers. So there's 3 layers, all identical in the in the layers panel, which presumably GIMP's got something very similar.
Yeah.
Yeah. And the topmost layer of that I turned to soft light. Now I do know that GIMP's got soft light mode, so I presume it's the same mode. You change that to soft light.
Yeah.
It looks very odd. Yeah. And then you merge the top two layers together. So there's obviously a way of merging layers in GIMP.
Yeah.
And then you go into the blend mode. So in some panel there will be a
Yes.
mode to the two layers blend together. So you change the blend mode for the topmost layer to color, and it enhances the color, and it ends up looking like the one on the right. So this is about a 30% increase in saturation in contrast rather in the A and B channels. And then this soft light mode in PixInsight, and the colors, it's brought the color out enormously, isn't it?
Mm. Mm.
Blue's always a problem for me. I think it's a problem for anyone in light pollution. People you just don't pick up the blues as much as people do in darker skies. So
sometimes people push the blue too far, and it looks
horrible, doesn't it?
It looks
it looks horrible.
Yeah.
I know I can do that as well. You can just put a curve on the blue,
Yeah.
mask it off. Yeah.
Dave, one question on the masks in the first column, right? How do you generate the masks to catch only the background?
Yeah, this is a tricky one. I can show you this. We can go into it now, actually. If I just so if I have to stop sharing, don't I? And then I have to go into share screen and go into PixInsight. So share PixInsight. So let me get up an image. It might be one of yours, Pramod. Oh, look. There you go.
Okay.
Yeah.
So that's your M51. And in PixInsight, there's a number of ways you can make a mask. You can just extract the luminance from that.
Yeah.
Yeah, which would be a mask. And I thought I'd got them here. Never mind, I haven't. So you just do, so in here you just go image extract lightness, and you've got basically a grayscale version, which you can then put on as a mask. Yeah. And you can
then invert it to get the stuff.
You can invert it, yeah. So that's an inverted mask. So so that is protecting the galaxy and the stars. Something you want to do, yeah. And you generally use something like that for a bit of noise reduction. And then there's another process called range selection. Now this I think will be akin to color select or something similar in GIMP.
Okay.
You can do a range selection in GIMP, I assume.
Yeah, you can do a color selection.
Color selection. This will be akin to that. So if you just click that button and then there you go, and you end up with a mask, some sort of mask.
Okay.
Basically got the galaxy on it and the stars, and you can use that to protect the white. So white allows, when you apply the mask in GIMP or whatever, white allows stuff through.
Yes.
Black stops it coming through. Yeah.
Yeah, it's exactly the same. Yeah.
Yeah, I think those concepts are the same. Yeah.
So within GIMP, I'm sure you can do that. You can do something similar to create a mask over the image. So if we go back to Photoshop. Just go into a different one.
So in your steps where you were boosting contrast in A and B, are you doing that before you apply the mask or after you apply the mask?
I was just going to show you the sort of stuff I do. So what I would do, let's just open one of the images. So that's so I made these up and put them in the wrong folder, which is why I can't find them. So here's your, so
share again, Dave.
you can see, have I not shared it? Have I not shared that?
No.
Can you see that now?
Yeah.
Yep.
Yeah. So I'll just run through what I do. So that's Pramod M51. So I've just cropped it and taken the background out and put a little bit of a stretch on it. And just to show you what I would do.
This is where the speed of the hand will deceive the eye now.
No, I'll go through it. So there's a range. So I made a range mask, and what I did, I took the stars out. So there's a utility process within PixelSite called StarNet, which allows you to take the stars out.
Ah, okay.
And it's just, you can get it. It's a standalone thing. It's extremely useful for getting stars out of things. So stars are a bit of a problem generally.
An irony in that.
They are a problem processing. So quite often you don't want the stars in there. I can show you why. So anyway, so there's Pramod M51. So first thing I'll do, I'll duplicate that. Yeah, because I'll work on a duplicate image. Yeah, so I'll turn it into lab color and then go over to the channels. Oh, I have a face-off outside my study window between a wren and a robin. Oh dear. Go into A and B. This is what I do. I'm sure people will tell me off for doing that. So select the A and the B channels and then go into adjustments. And I just do this. I just wind the contrast up to 30 or 40 or something. And then go back. And then just go in history. So I don't know whether this will come across, but you can do, that's what it looked like to start with. We've got a history button obviously in GIMP, and that's what it's like afterwards. So you can see it's bringing the blue up and the reds up within it. I can see that. Maybe a bit, I'll blow it up a bit bigger.
Yeah, we can't see a lot of change. Well, I can't see a lot of change.
Yeah, but in the histogram we can see it, right? So
can you see it on the screen?
Oh, I've got my pictures.
Yeah, you can.
The histogram clearly shows another
changed. Yeah, so you can see that. So if you could see this, you would see that the colours come up in the galaxy, but also the noises come up in the background, which is something you don't. That's where the mask comes in. So now that's doing the lab colour thing. So again, we'll go back to sorry. Red, green, blue. Move you all around, and then just create a copy layers, which is Control J in Photoshop, and then go to soft light, and again you can see that it's changed it again. Then you've got that layer and that layer. Merge those two together, and then go to color. And you can so that's with the lab color change, and that's with soft light. So you can see it's added quite a bit of color. It'll probably show more when I put that back over the original image, which is what I'm just about to do. So that's it. So merge those down, and then select the image, copy it. And this is the original image, and then put it back over the top. So I'll just toggle it, I'll just make it a bit bigger. So that's the color adjusted image, and that's the original image. You can see, yeah, and it's pretty good.
Yeah, the glow's coming out.
You can see the blue, you can see the blue stars and the spiral arms, and you can see this sort of reddy brown thing coming through. which the dust lanes and the gas clouds within the spire arms. So that's, I think it's pretty impressive, really. Yeah. And then what you can do, this is where the range mask comes in. You can add, so that's so layer 1 is the color adjusted layer, 2 is original, and you can put a layer mask on it, which is this thing here. And then if I take this range mask that I made in Pixel Sight, select it, and then paste it in there, you can see, so the red it's not coming through in the red. It's only coming through where you can see the galaxy. Just click it all, and what you see, I haven't changed the background at all now. I've gone back to the original background by using that layer mask. So the noise has gone back down again, but the galaxy has come up. You can see, yeah. Is that? I mean, all this stuff is in the mask and everything are in the folder that's on the BAS drive.
Right.
If you want it, so people can take a look at this and play around with it themselves.
Okay.
Yeah. So that would be, let's go back to that's my presentation now. Find it. Let's complicate this. Yeah, so that's so what I just did on Parallel 1051 is what I've done on exactly what I did on Andromeda there. And then I will add the luminance back over. So the signal to noise ratio on the luminance is vastly greater than it is on the RGB. But what I do I mean, you can do, there's two ways that you can do this. In Pixel Sight, you can just use something called LRGB combination, which gives you, basically gives you the same answer actually as this. Or in Photoshop, I copy the luminance layer and paste it over the RGB. Turn the blend mode to luminance, and then set the opacity of that layer to about 20%, and then increase the color saturation in the RGB, and then just repeat that about 5 times. That's just how I've done it for a couple of years now, and that's the end result.
When you say repeat 5 times, what are you repeating?
Putting the layer. So what I'll do is I'll copy the luminance layer, paste it over the top of the RGB.
Yeah.
Turn it to luminance so that only the luminance element is being used. Reduce the opacity to 20%, so it's not the full sort of strength of image going through. Wind the color saturation up on the underlying RGB image, and then flatten it, and then do that 5 times.
Ah, right. Yeah. Okay.
That's what we do. If in Photoshop, if you put the luminance straight over the top, it's just 100%. It just washes everything out. Doesn't do that in Pixel Sight, but it does in Photoshop.
Oh, I see.
In an iterative fashion, and you might, if you do that in GIMP, you probably have to use something similar.
Yeah, I think GIMP does something similar. Yeah,
I'm pretty sure it'll be much. I'm sure GIMP probably just copied. Ultimately, it's just copied Photoshop, so all the techniques will be the same. Because I imagine they're all originally Photoshop techniques that people have copied.
Yeah, and I think Cyril has basically copied Pixel Sight. So yeah.
Well, the maths is the same. I mean, the maths is the same for all of them, isn't it? So.
Yeah. I mean, exactly. I mean, the steps you're going through are the steps that we can go through as well. We're not using anything that has got something missing.
Right.
Yeah. So
So yeah, so I've done that. Yeah, so I've done that, and then finishing touches. It's maybe I've missed some stuff. I mean, you do a bit of color noise reduction. So there's a few things you can use for this within PixInsight, within Photoshop rather. There's just a thing called color block reduction, which is pretty effective. PixInsight, you can use any number of their noise reduction tools. TGVCR, whatever that stands for. Dave, do you know what that stands for? I don't know.
La 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 la.
Plus masks. I mean, you use masks with all of them.
Yeah.
You don't want to reduce the.
That's right. You're only affecting the background.
The background, really. Or ACDNR, I find to be most effective, despite the fact it's one of the very old ones.
I know the NR is noise reduction.
Yeah,
on
that's
the end of
it. I know. And then you can use. You can get rid of the background color as well. So if you've got any remaining sort of color in the background, you can use masks again, and you can reduce. I mean, PixInsight uses one of the either MMT, the multi-layer. Yeah,
this the middle letter either stands for linear or multi
scale or whatever.
Yeah, that's right.
Masks, and you can take the color noise. You can take the color out. You can take the noise out. You can also take the color out with it. Luminance noise reduction, you can use deep space noise reduction in Photoshop, or again you could use TGVCR in that, and then maybe I haven't put it in here, but you can do star reduction. So PixInsight has got a it's morphological transformation, isn't it, Dave?
Yeah.
So you'd have to create within PixInsight, you'd have to create a star mask. Again, which there's a tool for, and that would allow you to just do an operation on the stars rather than on the whole thing.
You have to watch you don't introduce artifacts there. Ringing artifacts is a common one, either a black ringing or a white ringing. Yeah, you can play around to your heart's content.
Yeah, especially if you're doing star reduction, it's best to err on the side of caution, because otherwise you do introduce stuff, particularly with the Photoshop thing, where quite a lot of people they go absolutely mad on the star reduction with Photoshop, because you just press it. Because some chap called Noel has come up with a whole series of little macros that run. But what it does, it makes your stars smaller, but it actually introduces artifacts all over the image, and people and people. Some people I've seen think they're real, but because you don't see them in Hubble photographs.
Yeah, that was one thing I struggled with. I was trying to use the techniques which guys tell on YouTube and so on to create star masks, right? And then you do it, and then you get this little black ring around the.
Yes, because it's overdoing it.
Yeah.
It's a little often, or a little and stop now before you muck it up. You know, and it comes down to predominantly, as Dave's opening gambit was, the more and better data you've got, the more you can do with it. You're battling just above the noise threshold anyway with your data, then really all you're doing is playing around with the noise and ruining the data you have got. So a lot of PixInsight's processes are very difficult to appreciate what they do unless you've got a really high signal to noise ratio in your data.
Right.
And then they can be quite profound. You think, oh, blimey. So sometimes their test data shows stuff very well. You try to do it with your own data and nothing appears to happen.
I know. But what you can do with a layers program and a mask, I mean, what you can do, because you do get the ringing artifacts, is you can do your star reduction on a layer, and you'll have all sorts of funny stuff going on. But then you can use the star mask again to apply, just to reduce stars to the underlying image. There's all sorts of stuff you can do with a layers based program that makes it a lot easier than PixInsight, which is why I use both. It's just so much easier. So anyway, so other things I do, adjust the levels. I was saying earlier, the last thing I do is the black point, and I generally set that. I don't know. presumably, again, GIMP has got some method of measuring what the background, what the intensities on the image are. And what people tend to do is to set the background at somewhere in the sort of low 20s, high teens to low 20s. So I can show you what I mean by that if you're not familiar. Is there any way to go directly from one screen share to another program on my desktop?
I don't think so, because I think you have to stop sharing and.
So if I go, so this is the little tool in Photoshop, this square at the bottom, and that's the color picker. So I can't see it. What does it say? It's saying this is the background levels, so you can see they're 48, 50, 44. So there's a bit of but you'd adjust that down, put a levels adjustment on it. You guys, you're in the way again. Oh. You just put a levels adjustment and bring that down to whatever. But with Pramel's data, you don't want to go too far, because he's got, that's probably a bit too far, isn't it? You've got the tidal tails, so you've got this out here, and you've got it. Actually, you can see on my screen, you can see it going out here. So how much time is in this image, Pramel?
This is about 50 minutes worth of data.
50 minutes. I mean, it's pretty good, isn't it? I mean, you've got some coma or something, haven't you? And maybe some guiding issues.
Yeah, there's no guiding at all. So,
but it's remarkably impressive, the amount of the depth you've got to in that time.
Which is what I said, right? I was impressed with that 130 EQ.
Did you see on Stargazer's Lounge the image that a bloke called Padre Peace did?
Don't know.
I
may have seen it. Don't know.
Have a look at that, because I can get it actually. I'll bring it up. I'll show everybody.
Okay.
You just give me a moment.
And to think, where I have my scope placed, it's directly facing the street light across the road. So I thought I'll get a big glare from it. But yeah, it seems to be doing fine.
Yeah, I remember when ages ago when John Barry Smith was showing what you can do with just the standard 50mm lens, just how deep he was able to zoom in on the thing and still pull out detail, and you think that's very impressive, So it's quite surprising.
The only thing which I think I'm struggling with is obviously the focuser on the 130 is not that great, so it's hard to get that pinpoint focus easily.
Yeah.
Wow.
That's M101. What camera do you think they used for that? That's an ASI 224. That's your camera.
Okay. Yeah.
So how much data?
A lot of data. It's a huge amount of data. It's 18 hours you spent on it.
Right.
He binned a load of it. And it's a 4.5 inch refractor on a Skywatcher EQ6 or something. But it's just amazing. It's amazing.
Yeah, it is. It is. I think that ASI 224 is a splendid camera.
What he did, I mean, you can see the post, but he took darks. It's so much data. It's over quite a few nights, and he took darks as he was going along to make sure he had some matching darks to fit against them. So as the ambient temperature changed, he kept taking more and more darks to get a good calibration on it. But it's quite incredible. It's got very good detail. I mean, he's got incredible detail right into the core on it.
Yeah, Mark, you said it's good for planets, right? So that's how I bought it. I said, okay, I'll be able to do some planetary stuff, but I wasn't sure what I'll get on the galaxy side.
It's amazing what they're doing, isn't it? What was that? I mean, it's a tiny little chip, isn't it? The
Yeah, it's 4 mil by 3 mil or something. Yeah.
Yeah, you see, you guys went down the wrong route. You could all be living in luxury.
What do you mean? What do you mean?
I missed one by that chap. He took 31 hours of exposures and then rejected it down to 18. Why did he? I mean, that's nearly half of it.
I think I can't remember what he said. Probably cloud or something, Mark. Or maybe,
Oh, okay. Drifting stuff.
Yeah. Because
He probably used PI blink and it said, "Sorry, mate."
It really does. Yeah, the cloud really does mess stuff up. Really does mess it up.
It could even be just in drifting stuff, can't it? I mean, you may not see it yourself, but it's just
it's there because it raises the background up, and some of the programs think that it's signal.
And it's not uniform. I remember, Bob, when we were out in Tenerife, you and Dave and the gang were getting very cross with all the dust because it had a similar effect, all the dust in the atmosphere.
Yeah, and unfortunately, because that drifts across the frame over time, there's nothing you can do to remove it. But I seem to recall when we got involved with that, the Hubble Deep Fields challenge some time back, that I probably threw about half of the data I collected away, and I still ended up with about 9 hours worth. But I think you get to a point where you look at a few frames and you go, on its own, it's not too bad. But when you're trying to sort of get the best you can, you start getting super critical on which frames you keep and which frames you throw away.
Yeah. So you can do a bit of set your levels. You can sorry. You put a curve on it and adjust the contrast on it. So the way to do that is to put an S curve on it. So just pull it down a bit there and pull it up in the middle. Just put a bit more contrast on it. So you blacken it by pulling it down at the bottom. You're darkening the background, so you can do that. Flatten that down, and then you can sharpen it. Now you can use, there's all sorts of things you can use. I mean, if I'm in Photoshop, I use unsharp mask, which I'm sure again GIMP has got.
Yes.
Yeah. But I'll show you what it does to the stars. It's the stars that are the problem. So here, sharpen, unsharp mask. And you can see, I mean, that sharpened it, isn't it? So it sharpened the galaxy nicely. I'm not being too fussy about how much it's got, but it's made the stars look a bit of a mess, I think. But you can get around that, of course, because you can go back to our trusty range mask, which hasn't got any stars in it. And so that you only apply over the galaxy, and you can adjust it. You can adjust the opacity of that, whatever. And what I tend to do with sharpening is to produce a mask which to start with hasn't got any stars in, but then I actually take the stars out, so that the softer stars from the unsharpened layer show through. But you can see, I mean, sharpening the core, isn't it, up quite nicely. You can just play around until you get something you like.
Very good. Thank you, Dave.
That's it. I mean, I think the technique.
Yeah, that's lovely.
So it's gone. Yeah. So if we go back
Fantastic.
to, I can't open it because I need to save it. To show you a comparison. So that's the original that came out, stretched out of Fixed Insight, and that's with those color adjustments and a bit of sharpening.
Quite dramatic change there.
Very good, very good indeed.
So yeah, so you say again, you've got the dust lanes and the hydrogen clouds and whatever, and you could put, we could put a bit of color blotch. I would just put the color blotch reduction on it actually. Does just say too many things. So these are the astronomy actions, Neville's actions. I wonder if there's something similar for GIMP.
This is the, what are these actions?
They're a series of actions. This is basically processes, automated processes that
okay.
like Noel has written that you can buy. So that's all over the place.
Yeah,
I haven't seen anything which is for the astronomy side of stuff.
I haven't
sure
seen anything, but
yeah.
there are a lot of astronomy sort of add-on tools and things.
Yeah. So what I've just done, it's worth investigating. So what I just did, I did a bit what's called color blotch reduction. So if you blow it up, so that's without the color blotch reduction, and that's with it. So can you see it's gone, particularly in the background. So it's quite a mottled appearance now. Comes grey. And again, you can do this. I can put the star reduction. Can't find it. Make stars smaller. So you can see that's the effect of both the color blotch. That's star reduction. If you run it more than once, it makes a bit of a mess. I'll show you what it does. I mean, just one the galaxy. As you run it. You can see all the artifacts coming out, these little blobs. Where it's recognizing, I think it starts to recognize the noise of the star.
Yes, and then tries to reduce around it, yeah.
It's the old adage, isn't it? Less is more.
Well, more, but with astrophotography, more means less, doesn't it? That's the thing.
Well, exactly, yeah.
The more data you've got, the less it has to do to it. Not that it stops me playing around for hours on end. So that's basically what I do.
Excellent. Thank you very much for that, Dave. That's very insightful.
You must do that during the day, because of course you're watching films and kipping when the thing's actually taking images.
I never do any of this at night. It keeps me awake. It keeps me awake, doesn't it?
Yeah.
So on the if I'll just stop sharing.
Yeah.
And then I'll share my screen again, and I'll show you what else is 5 pixels. So it's another. It's if anyone fancies the play, I'll put this up
Okay, excellent.
if you want to have a play with that.
And what we've got to make it into, an M51?
You don't have to do it. It's not for you.
It's the right shape. You've got a big one and a small one, you know.
Yeah. So that's, I think that's about.
That's a good example of there not being any real background there, because it's all nebulosity.
You can't see where it is. The points, aren't there? So
yeah, you got to find little squares. That's where the preview, what's it, area of interest, you can use on some of the PixInsight things. I don't know if you can do similar, where you can go and make a little tiny preview of what is the limited amount of sky that there is, or background that there is, and then it will take that into account.
Yeah.
you just run it on. This is dynamic background extraction. So there's dust all around here. This is the edges of the horse. Here. There's a bit there, isn't there? And there's probably...
Cyril does attempt to select only the background, but of course it's you will get points within in your nebulosity, so you do have to go and remove them.
You don't need that many points. It might be a bit down here.
No, and that's the bit that's come out, because a lot
of people.
The automatic program throws down loads of points, of course.
It's rubbish. You don't need...
But if you don't need that many, that's quite useful to know.
Well, that's the gradient that comes out. Yeah, was you could you could do, you could plaster it, couldn't you? You could set your tolerance up to 1.5 or something. And go in here, sample generation. Oh, let's have 10. Oh, look, this is just absolutely plastered, and this is what the mistake people make at the beginning.
Yeah.
And then let's have a look, see what it does. Subtraction.
Yes.
I'll just show you the gradient. It'd be horrible.
Yeah, yeah.
That's the nebula, isn't it? I mean, that's your iron nebula, and
you've just taken it out.
Half of it out. That's you can see what's happening.
Yeah, it's where it's missing now.
It's really dark.
Yeah.
Don't do that, guys.
Been quite amassed.
Yeah, so that was taken with a 200mm lens. And an APS-C. It's called camera, but an APS-C camera.
Yeah, with just the lens on. Yeah, very good indeed.
I mean, I've cropped it right down. It's an absolutely enormous file. It's about 300 megabytes, the image. I thought it was a bit too big. But, just something to have a play with, really, if you want to have a go.
Yes, thank you.
And you've got your M81 and M82 as well, which you can have a go at.
Yeah. Yes, because data is the one thing we're trying to collect, and as we all know, that's dependent on.
Yeah, you can't. Yeah. Well, I'm happy to share it. I mean,